Hello students, welcome back to our YouTube channel Geeks for Geeks GATE Computer Science and Data Science. So in this video we are going to continue the topic eigenvalues and eigenvectors. So in the last class we have discussed that X is a, let's suppose A is an n cross n matrix. A is an n cross n matrix of order is n cross n. Then I am interested in finding out a vector X. I am interested in finding out a non-zero vector X such that I'll get Ax is equals to lambda x. I'll get this. Ax is equals to lambda x. I want to find out this eigenvector x such that I'll multiply the vector itself with the matrix. I'll get a scalar value and a vector itself. Right? So, and this x is called your eigenvector. Eigenvector and lambda is called as eigenvalue. Eigenvalue. Now we have also discussed the method to solve this, to find out eigenvectors and eigenvalues. What is the method? Let's just do a quick revision and then we'll move to further topic. Right. So what we have discussed that to find out eigenvalues, what would we do? I'll solve determinant of A minus lambda I is equals to 0, which I called as my characteristic equation. I'll solve this determinant of A minus lambda I is equals to 0 and I'll get the eigenvalues here. Now for eigenvectors, to find eigenvectors, what would I consider? First, I'll consider all the eigenvalues which I get from the first step, that is lambda, and corresponding to that, I'll solve the system. A minus lambda I x equals to 0. And we'll get for each of the lambda eigenvalue, I'll get corresponding eigenvectors. And we have seen that in last class, there may be a possibility that if we have a repetition of eigenvalue, then we have more than one eigenvectors, right? We have more than one eigenvector. So here I can say that, just a minute. Here I can say that eigenvectors जो भी हमको मिलते हैं would be less than equals to okay, इस ऐसे नहीं लिख के ऐसे लिखते हैं, lambda equals to 1. If lambda is repeated multiple times, let's say lambda is repeating k times, if this eigenvalue is repeating k times it is repeating, then eigenvector number of eigenvector corresponding to k would be, corresponding to lambda will be less than equal to k. So there might be a possibility that I'll get k eigenvector, there might be a possibility I'll get k minus 1 eigenvector according to the number of free variables. We have seen that in last video. Right? So I can have any number of vectors possible. Right? So there might be a possibility that if lambda is equals to 1 comma 1 is repeating 2 times, either I can have one eigenvector or I can have two eigenvectors, not more than that. I cannot have more than two eigenvectors. And at least for each of the eigenvalue, I can mention that as well, for each eigenvalue there is at least one eigenvector. Right? So these 2 points you have to remember, like these are the takeaway from my last lecture. So I think till here anyone like does not have any confusion, right? We do not have any confusion till this point. Now next we have to discuss some properties of eigenvalues. This is one of the important topic, because every time it is difficult for us to find out eigenvalues for a 3x3 matrix, 4x4 matrix. So does we have any properties which would make our work easier, right, which would give us information so that I can like have slight better information other than finding out eigenvalues, right? So we are going to discuss that. So what are those properties? First property is eigenvalue of symmetric, real symmetric and Hermitian matrix are real. Hermitian matrix हमने नहीं पढ़ा है और अभी हमारे यूज में भी नहीं है, गेट के सिलेबस में भी नहीं है, और यहाँ पे भी स्क्यू हर्मिशियन मैट्रिक्स और यहाँ पे यूनिटरी, ठीक, अभी के लिए हमारे यूज में नहीं है, जितना है उतना पढ़ते हैं. आइगन वैल्यूज ऑफ रियल सिमेट्रिक मैट्रिक्स आर रियल. So if we have a symmetric matrix, its eigenvalues are always real. And if we have a skew symmetric matrix, first of all, do you remember all of you what is symmetric? A transpose is A. Skew symmetric, A transpose is equals to negative of A. So if we have A transpose is equals to A, matrix would have real eigenvalues. And skew symmetric matrix, A transpose is equals to minus A, then the matrix have either purely imaginary eigenvalues or zero. We can have any one of the case. Now eigenvalues of orthogonal matrices are of unit modulus. What are orthogonal matrices? Orthogonal matrices are those matrices where A transpose A is equals to identity. A transpose A is equals to identity. So they would have a unit modulus. So that means if A is a orthogonal matrix, then it has eigenvalue either 1 or minus 1. It has eigenvalue either 1 or minus 1. It can be iota or minus iota as well. Yeah. Iota and minus iota as well. But orthogonal ki usually 1 or minus 1 hoti hai. Have unit modulus. You just remember that unit modulus hota hai. Now another point we have here is lambda 1, lambda 2, lambda n are the eigenvalues of A. Then k lambda 1, k lambda 2, k lambda n are the eigenvalues of k. So what does it mean? Let's suppose A is a matrix having eigenvalue 1, 2, 3. Then 5A would have eigenvalues 5, 5 into 2, 10, 5 into 3, 15. So these are the eigenvalues of 5A. So once I know the eigenvalues of A, I do not need to find out individually the eigenvalues of k into A. I can simply multiply the k with the eigenvalues. Next we have is lambda 1, lambda 2, lambda n are the eigenvalues of A. Then 1 by lambda 1, 1 by lambda 2 and 1 by lambda 1, lambda n are the eigenvalues of A inverse. So if I'll ask you what are the eigenvalues of A inverse, and make sure A inverse exists. If A inverse exists, because if A inverse does not exist, then you would not, like if A has 0 eigenvalue, then A inverse would not exist. 1 by 0, that would not be a problem. So A inverse exists, so eigenvalue would be 1 by 1, 1 by 2, 1 by 3. Right, that's how you can find out the eigenvalues of A inverse. Next we have, if lambda 1, lambda 2, lambda n are eigenvalues of A, then lambda 1 to the power k, lambda 2 to the power k, lambda n to the power k has eigenvalues, are the eigenvalues of A to the power k. Let's suppose I need to find out eigenvalues of A cube. That would be 1 cube, 2 cube and 3 cube. That is 1, 8 and 27. These are the eigenvalues, right? So let's do one problem. Let's say A is a matrix which has eigenvalues 2, 4, 3. You need to find out A square minus 5A plus 2I. What are the eigenvalues of this matrix? Think about it and try to solve it. Just pause the video and try to find out the eigenvalues of A square minus 5A plus 2I. Find out the eigenvalue. So what would it become? You would substitute A is equals to 2 square. 2 square minus 5 into 2 plus 2 into identity would always have eigenvalue 1. So it would be always 1. Another one is 4 square minus 5 into 4 plus 2 into 1. Another one is 3 square minus 5 into 3 plus 2 into 1. What would I get on solving? 4, 5, 6 minus 10, that would be minus 4, 16, 17, 18, minus 20, minus 2. Just check the calculation by yourself as well. 10, 11, 3, 3 is 9, 10, 11, minus 15, so that would be minus 4. Eigenvalues is minus 4, minus 2, minus 4. And also one thing you can check, that if A has 2, 4, 3, all eigenvalues are distinct. All eigenvalues are distinct. Then this matrix, which is we are getting it here, a square minus 5a plus 2i, may or may not have distinct eigenvalues, right? So any of the matrix you would write down. So this is like these are some of the important properties. We are going to discuss more properties, but you guys just go read all the properties once by yourself, because then we are going to solve questions based on that. So let's take a minute and read all the eigen properties, because in GATE exam all the questions came from these properties of eigenvalues majorly. Okay, so let's move for further properties. Now they are saying that eigenvalues of A is equals to eigenvalues of A transpose. That means A transpose and A have same eigenvalues. So if you have eigenvalues of A, you do not need to find out eigenvalues of A transpose. Now these two properties are really important for us. It says that sum of eigenvalues is equals to trace of A. So that means if I'll take sum of eigenvalues, that is equals to sum of diagonal elements, because trace is what? Diagonal element sum. Product of eigenvalues is equals to determinant of A. And simply you can find out eigenvalues of a 2 cross 2 matrix using this. Let's take one matrix 4, 5, 2, 1. Let's try to find out the eigenvalues here. 4, 5, 2, 1. I think right matrix I have written. 4, 5, 2, 1. We have the eigen matrix 4, 5, 2, 1. And like instead of the method which we have already discussed, determinant of A minus lambda is 0, I need to find out eigenvalues using this. So how do I find out? I'll say sum of eigenvalues. It has two eigenvalues, lambda 1 plus lambda 2, that would be 5, and lambda 1 into lambda 2, that would be 4 minus 10, that would be minus 6. Now I want eigenvalues in such a way that sum would be 5 or product would be minus 6. So I can just take lambda 1 from here and substitute it here. You can do that. But instead of that, I am just fitting two numbers so that I'll get sum is 5 and product is minus 6. So can I say that it would be 6 comma minus 1? Sum is 5 and product is minus 6. So using these two properties, you can directly find out eigenvalues of two matrices, and we are also able to solve some of the questions based on 3 cross 3 matrix. We cannot find out directly because then we have two equation, 3 variable. We will not be able to solve directly, and they are not linear equations, right? Because we have a product. But that would be helpful in different types of question, these two properties. Maximum number of distinct eigenvalues would be size of A, right? If A is an n cross n matrix, I can have at most n eigenvalues. उससे ज़्यादा नहीं हो सकती. Eigenvalues of AB is equals to eigenvalues of BA. AB की जो भी eigenvalues हैं, that would always be equals to the eigenvalues of the matrix BA. कैसे भाई? देखो ये दोनों चीज़ें सही होंगी. Trace of AB is equals to trace of BA and determinant of AB is equals to determinant of BA. So we can say that eigenvalues of AB is equals to eigenvalues of BA. Now the last property I have written here, that the eigenvalues of a triangular matrix or diagonal matrix is given by its diagonal entries. So if we have a upper triangular matrix or lower triangular matrix, the diagonal entries would give me the eigenvalues. I do not need to solve it for them. Right? I do not need to solve it for them. Now, let's go through all of these properties once by yourself, and then we are going to discuss questions. Then we'll be discussing questions. We'll be discussing question based on these properties, which has been asked in GATE exam. So just go through it once. Now let's solve the questions. So this is one of the question given as, consider the matrix as given below, 1 2 3 0 4 7 0 0 3. They're asking which of the following options provides the correct eigenvalues of the matrix. Correct eigenvalues of the matrix. So it is upper triangular matrix, and if it is upper triangular matrix, then the diagonal entries would give me the eigenvalues. So 1 4 3 would be my eigenvalues. Option A is correct here. Right? It's simple question. So this question has been asked in GATE exam. So option A is correct here. Let's see next question. Guys, every question, just pause the video when I share it with you, because you have already read the properties. So try to solve it by yourself, and then if you do not get it, then look for the solution. Consider the following matrix. Eigenvalues of A are 4 and 8. Then you need to find out the values of X and Y. So what would you do? One thing you know, that trace of A is equals to sum of eigenvalue, that is eigenvalue. So 2 plus Y is equals to 4 plus 8. So that would gives me Y is equals to 10. Now I need to find out X. So what is? I know that determinant is equals to product of eigenvalues. Determinant is, because it is a 2 cross 2 matrix, 2y minus 3x. Product is 4 into 8. So y you can substitute, 20 minus 3x is equals to 4 into 8. Sorry, that would be 32. So you would take this here, x would be minus 4. On solving, you would get x as minus 4. X is minus 4 and y is 10. So this property, trace is equals to sum of eigenvalues, help us, and determinant is equals to product of eigenvalues, help us to solve this question. Now let's try next question. Next question, the larger of two eigenvalues of the matrix. अब ये देखो, ये तुमको दिख रहा है 4 5 2 1. You can either solve it by yourself. मैंने अभी तुमको बताया था, इसको मैंने यहाँ पे solve किया था, eigenvalues निकाली थी. 6 minus 1, it has the eigenvalues. It has the eigenvalues 6 minus 1, and they are asking larger of two eigenvalues. Which one is larger? 6. 6 is larger of two eigenvalues. Right? Now let's see next question. They are saying that two eigenvalues of a 3 cross 3 real matrix P is given as 2 plus square root minus 1 and 3. They are asking for determinant of P. Now P is a 3 cross 3 matrix. So we would have 3 eigenvalues. N cross n matrix होती है, n eigenvalues होती है. There may be a repetition, there may be distinct, but there should be n distinct eigenvalues. But here we have 2 distinct eigenvalues. Now I want to know which one is repeating or what would be the third eigenvalue. I want to know that. So I'll think about it, guys. Just think about by yourself, and you can see that we have this root is 2 plus iota. And eigenvalues are what? Are the roots of the polynomial. Eigenvalues are roots of a polynomial, and roots of a polynomial always occurs in pair. So 2 plus iota is a root, then 2 minus iota would always be a root. So if one of the eigenvalue is 2 plus iota is there, then 2 minus iota would always be there. So we have 3 eigenvalues as 2 plus 1, 2 plus iota, 2 minus iota and 3. We have to find out determinant of P. So determinant of P would become iota square would be minus 1. I square is minus 1. मैंने इसको यहाँ पे square root of minus 1 is I. वो I लिख लिया. So 4 plus 1 into 3. That would be gives us 15. So determinant of P is equals to 15. So this question like you can solve it using the property determinant of P is equals to product of eigenvalues. But one more common sense is required that eigenvalues are the roots of the polynomial, roots of a equation, and quadratic complex roots always occurs in pair. You have to remember that to solve this question. Now let's see further questions. So they have given the eigenvalues of a matrix 1, 2 and 4. The determinant of A inverse transpose they are asking. They are asking the determinant of A inverse transpose. So what would you do? What is determinant of A? 1 into 2 into 4. That would be 8. Now I need to find out determinant of A inverse transpose. One thing I know that determinant of A transpose is equals to determinant of A. So that means it is equals to determinant of A inverse, and A inverse determinant would be 1 by determinant of A. That would be 1 by 8. And if you would write down it decimals, 0.125 would be the answer. Right? So here 0.125 would be my answer. Now let's see next question. This question says that the matrix A has 1 to 1 transpose and 1 1 0 transpose as eigenvector with both eigenvalues 7. Traces to, they are asking determinant of A. I know that 7 corresponding to 7 I have the eigenvector 1 to 1 and 1 1 0. And because I am getting the eigenvector of order 3 cross 1, so A is of matrix of order 3 cross 3. So I need 3 eigenvalues. Let's say lambda 1 is 7. So lambda 2, lambda 3 are also required. Right? So trace is given to me 2. So I know one thing, lambda 1 plus lambda 2 plus lambda 3 is equals to 2. But again, I am not able to find out the second and third eigenvalue with only this equation. So what would be the second eigenvalue? One thing you can notice here is corresponding to 7, I am getting 2 eigenvectors. Corresponding to 7, I am getting 2 eigenvectors, this one and this one. So this eigenvalue must be repeated. This eigenvalue must be repeated. I told you na, in this first, like where I have written number of eigenvector corresponding to b lambda will be less than equals to k. ठीक है, तो that means 7 would occur 2 times. 7 would occur 2 times. So lambda 1 is 7, lambda 2 is 7, 7 plus 7, lambda 3 you would be able to find out using this trace condition. So we will get minus 12. So what is a determinant here? What would become the determinant? Determinant would be 7 into 7 into negative of 12. That would give me negative of 588. So which of the option matches? None of the option matches. None of the option matches to our answer. So here option D is correct. Right? I think this is a question from GATE mock 2018. Right? They have asked this question in mock exam. Let's see this question. Consider a matrix A where A is equals to UV transpose and U is a matrix 1 2, V is a matrix 1 1. Largest eigenvalue of A is, A की eigenvalue निकाल लिया. So first what would we do? We'll find out U into V transpose. तो U V transpose find out कर लो. So let's find out U V transpose. U is this vector. V transpose would be, you would take a transpose 1 1. So I'll get a matrix A would be 1 1 2 2. Now I need to find out the eigenvalues. Largest eigenvalue बतानी तो lambda 1 plus lambda 2, because I find it easier तो मैं इससे करती हूँ. And lambda 1 into lambda 2 would be 0. What are the possibilities कि sum 3i and product 0? Product 0 तभी आएगा if one of the eigenvalue is 0. So let's take lambda 1 3, lambda 2 0. So 3 and 0 are the eigenvalues. They are asking for the largest, that would be 3. That would be 3. Now let's see next question. So this is a next question. It says that which of the following is /r are the eigenvectors for the matrix given below. So you can see that it is a given 4 cross 4 matrix. Would it be possible for us to find out the eigenvectors corresponding to this matrix? First I need to find out 4 eigenvalues. Would it be possible? No. So what would I do? I am going to use this, that if I'll multiply the vector itself and I'll get the if I'll multiply the matrix with the vector, I'll get the vector itself with a scalar multiple lambda. So I'm going to use that. So for that, what I'll do, I'll go through the options, right? I'll take this vector, multiply with this matrix and see I'm getting lambda x or not. And for B, for C, for D, I'll do the same thing. So let's do for A part, -1 1 0 1. I'll multiply फर्स्ट रो फर्स्ट कॉलम, एक ही कॉलम है तो फर्स्ट रो से मल्टीप्लाई करो पहले, -1. सब लोग एवरीवन वुड मल्टीप्लाई बाय योरसेल्फ. 1 -20 + 15 +5 that would be 0, -32 + 21 that would be, this would be 1. So you can see that for first vector we got A into x, this is a x vector 1x. So this is an eigenvector. Now I'll check for B as well. For B I'll check. I'll do the same thing for B. 1 0 -1 0. So what would I get? 9 -9 + 2 -9 + 2 -7 and -8 + 3 -5. अब देखो यहाँ पे 0 था, यहाँ पे -5 आ गया, तो नो मैटर व्हाट यू वुड टेक कॉमन, ये कभी नहीं बनेगा ये वेक्टर. तो या तो अगर तुमको चाहिए तुम पूरा सॉल्व कर लो. आई एम नॉट सॉल्विंग इट, सो बी ऑप्शन इज इनकरेक्ट. Now option C and D you would find out as correct. Simple multiplication है, just solve it by yourself. You would get A, C, D are your correct option. Right? These are the eigenvectors, but B is not an eigenvector. A, C, D are the eigenvectors. B is not an eigenvector. Okay, so yeah, so like these are different types of questions we have solved for this eigenvalue and eigenvector properties. Now later on in the next class we are going to discuss about Cayley-Hamilton theorem. So if you feel like any doubt or any question, you can just let us know in the chat section, and there is one homework question for you. So just try to think about it. It is little bit different. Just try to think about it and let me know the answer in the chat section. If you do not get it, let me know that as well. We are going to discuss it in the next, we'll discuss it in the next class. Yeah, so this is a question. Okay, so yeah, that's all for this video. Let's continue in the next video, in which we are going to discuss Cayley-Hamilton theorem. Thank you for joining.